Greetings. In this video, we're going to take a look at how we configure a MySQL database. This should sync up pretty well with the first part of your project, where you configure and design your own MySQL database and populate it with some test data. Now, there's a couple of links that will be provided in your project that you're welcome to link to and go directly to your database, but I sort of want to walk you through the process if you were starting from scratch. So, if you want to set up a database with FIT's site, there's an option available through our IT section that gives you your own MySQL database for your own personal use. Now, right here I have the view of the FIT site. This is it.fit.edu, and if you visit this site, you should see something like this with a number of links on the left side, which includes administrative systems, computing, printing, and a number of other things that we were not going to look at today. In particular, what we want to look at is the accounts and email section. So if you click on the accounts and email section, you should see an option called personal and group web pages. So give that a click, and then click on personal web pages at the top. You'll get some frequently asked questions, and this is perhaps the quickest way to get to it, is just selecting the very last question where it says how to create an additional MySQL database with your Trax account. Clicking on that link will give you the instructions through the whole process. In fact, you're welcome to just visit this and pause the video, get yourself familiar with all the services offered here, and resume at your leisure. But at this point, what we're going to do is click on this very first link at the top where it says the initial database can be created using the instructions found here. This gives us the IT resources link. This is how we actually start a new database. So if you actually had one existing, you wouldn't bother with this particular link. But we're going to click on it right now just to show you how it goes. So this would be the view that you get when you start a new database. It'll give the option to name your database, and in this case I already have an existing one. It shows you where the host is. Now this will be useful later on when we do some coding. You know, when we work with applications, we have to tell it where our database is actually being stored. So this would be the URL of the host to access our database. But for this initial part, we won't need to worry about it. It also gives you a link to the actual access, basically the user interface, which uses a program called PHP MyAdmin. And all this really is a nice shell on top of MySQL. It gives you some little features, little couple bells and whistles to make your life a little bit easier rather than working with MySQL from a command line. So I've already set up one. I'll give you a moment if you're following along to create one of these. It should ask you for a password as well. Just given a password, there's a couple of password rules: numbers, letters, lowercase, symbols. As long as you follow along those passwords, you should be fine. All right, so the next step I'm going to do is click on this PHP MyAdmin access here. And there should be a link to that directly as well in your project, but again, you're welcome to follow along step by step here as well. This is the view of PHP MyAdmin, which is our entryway into MySQL. And as a DBMS, it's a fairly lightweight interface. It's pretty easy to get around. There's not a whole lot of additional features. It's not a whole lot of things you might see in something like Oracle or SQL Server, but given that it is lightweight, it's easier for new users to get into. It tends to be less, since we're not focusing on some of the really extreme levels of usage, we don't have to worry too much about performance at this point. So on the left-hand pane over here, you're going to see the name of a database. It should probably be named after your PAWS ID, your Trax account. And at the beginning, you probably won't have anything in it. If you click the little plus, you probably should just have absolutely nothing in there. I have a couple of extra ones in here. We are just going to ignore these for now. At this point, we're just going to assume this is a blank database for you, so you probably won't see anything starting. Now, to start populating our database, we first need to have tables. So if you don't have any tables, we need to start putting some in. So using the examples we have in the project, we're going to create a student table. So down here at the bottom, there is this little input box that says name and number of columns, and this is how we start putting in our tables. So for the student, we're going to put in the name student as our table, and we're going to give it 5 columns. We'll click go. Now at this point, you're going to get a new screen. This is the screen where we decide what the column headings are going to be, meaning what the attributes are. So in the case of the student, we'll have a primary ID, a last name, first name, maybe a middle initial, maybe their student number. There's a lot of different things we can put in here. So I'll just keep it simple for now. So the first one, we'll just say the student ID. Second one, we'll say last name. Third one, we'll say first name. We'll say middle initial. And their student number. The second column here is the type. The type determines what type of data is being stored in this column. For example, if we had an int or integer, we would be storing whole numbers. If we had a float, a double, we would be storing values with decimal points. If we had just text strings, we would want to use varchar or text. Text is specifically for larger amounts of text. There's a bunch of other different types, such as date, there's booleans, quite a lot of other options. You're welcome to explore these at your leisure, and I encourage you to research the specifics of each one. Most DBMSs will provide a certain number of general types across the board. Some of them will have their own specific ones. Ultimately, it determines how much space this stuff is going to take on the physical drive and how it's optimized in terms of perhaps searching. So for example, if we were going to be searching a lot on dates, we might want to use the actual date format. The counterpoint to that is you're going to have to make sure that you store the date in a specific format. For example, dates can be 2 numbers / 2 numbers / 4 numbers, or 2 numbers / 2 numbers / 2 numbers, depending upon how you want to format it. There's a lot of variety you could do. So if you go down that path of choosing a specific type, you want to make sure the data you put in is going to be formatted correctly, otherwise you're going to run into errors. Now in this case, we're going to change only a few of these. We'll change the last name, first name, and middle name to varchar, because they're going to be text. We also want to change the length and values. This determines how much space we want to set aside in the physical row. If we want to have 10 spots, 20 spots, 30 spots, it's up to you. Typically what you want to do is have the length in powers of 2. Physical databases are binary. They take up binary spots, and powers of 2 are the most efficient ways to partition your database. So for example, if we use 0 through 255, we would have 256 locations. This power of 2 gives us an even amount of space so we don't have to chop up bits and pieces of the physical drive. We'll do this for the other ones, even though we probably won't need all that space, but for the sake of simplicity, we'll just keep it at that. The only other thing you really want to worry about in this view is over here on the right, the index type. So the index here will determine which one is primary and which values need to be unique. And in this case, we really want to focus on primary. We want primary to identify our student ID over here, because a student ID is the unique identifier for this table. We'll only ever have one student ID. We'll start at 1, 2, 3, 4, and keep on going. We would never repeat one after having used it. By changing this to primary, we enforce rules in the table and the database. So further on down the road, when we start making relationships, this will all go together rather smoothly. Once you're happy with how your table looks, we're going to click the Save button here at the bottom. Now back in our main view, and to get to this view, if you ever reach the point where you don't see it, you can always click on your table on the left here and click on Structure if that view is not available. You'll now see the student at the top, and you can click on Browse and Structure to get some information. Structure gives us this similar view to what we worked with before, where we can make edits and changes, and we can see that student ID is our primary key. Now if we click Browse, what happens is it gives us this nice little built-in SQL statement, which basically says grab everything from student. At this point, there's nothing in student. We haven't put anything in it. So if you're going to start testing out some data, we want to do some inserts. So we're going to want to select the Insert button over here on the top, sort of in the middle. This will give us the option to put in values for each of our columns. So for example, with the student, we would say 1. I will say Smith, John, middle name, say M, and we'll just give them a random 900 number. And we'll click Go. And now it inserts, it does all the SQL for us. It does the insert into the database name, the table name, the column names, and the values. It's a nice way of generating some SQL code without having to go through all the pain of making sure our format is right. Now when we click on Browse, we're going to see a little snippet of all the values that are inside our database. And here we can see there's student ID 1, last name Smith, John, M, and there's our 9,000 number.